Hello, I'm Natalia, and I am software engineer at Guild. How many of you have heard about Guild before? Oh, wow, that's actually a lot of hands in the air. Have you actually shopped anything at Guild, or do you know Guild Tech as organization of developers? Anyone shopped anything at Guild website? No, not really. Just one. Okay, so let me tell you a little bit about Guild. So Guild is an online retailer offering its members merchandise and experiences at discounted prices. And the business model is based on flash sales. So there is a new flash sales starting every day at noon Eastern Standard Time. So it's around afternoon in Dublin. And those sales have limited stock. So this creates this very interesting technical challenge with millions of members hitting our website within just a few minutes every day. So this generates this characteristic massive spike in requests per minute to our backend services within just a few minutes every day. So it's quite interesting. And about 60% of our revenue comes from the website, and 40% comes from mobile applications. So in addition to supporting mobile web and responsive design, we also decided to implement native applications for both Android and iOS. And what you can see on this slide is our iOS application. This application was first released in 2009, so it's been around for a while now. And it was implemented in Objective-C, obviously, because it was a while ago. And because this application must communicate with network-based services all the time, so it has to make API call to fetch the list of sales for the day, then it has to make another request to get the products for the sale, then we need to enable users to add products to the cart, and proceed to checkout and so on. So it's this constant communication with backend services. And unfortunately, or fortunately, our backend services have been evolving very quickly. So there was a lot of changes on the backend side of our application. And we faced this issue of not being able to Guild iOS application often enough to keep up with those changes. Probably, as you all know, it used to be quite painful and quite time-consuming to go through the whole release cycle through the App Store to release new version of application. So to avoid this pain of maintaining a range of old version of client applications and to be able to release bug fixes quickly. So imagine if we released an application with a bug during the checkout, so no one would be able to buy anything. And then for a few weeks, we wouldn't be able to submit new application to the App Store. That would be a disaster, and our revenue will be heavily impacted. So we needed to figure out a way to be able to update our application. And to solve this issue, we implemented a platform. It's called Mockingbird Data Environment. And this platform allows, it lets its iOS application adopt to server-side changes long after they have been released. And this platform served us for a good few years in production, and we finally open sourced it just last year. So if you're interested in this solution, please take a look at the GitHub. Our adventure with Swift started last year when Guild partnered with Apple to implement the first e-commerce application for Apple TV. And what you can see on this slide is a screenshot for the Apple special event from September last year when Apple TV was announced. And this is our CEO, Michel Peluso, doing demo of Guild application during this Apple event. So we were all very excited because Guild was featured during Apple event. And also to deliver this application on time for the launch of tvOS, our mobile team has to work with Apple TV devices long before they were publicly available. So they were working under those strict secret agreements. And they had to implement this whole Guild for tvOS application from scratch and in Swift. And our focus now is to rewrite our existing Guild iOS app in Swift, keeping common base of reusable components for both iOS and tvOS. And whenever we implement some piece of functionality in Swift that we think can be useful for a wider audience, we open source it. So you can take a look at GitHub, and under the umbrella name Cleanroom, we already released few open source libraries that can be useful for Swift developers. So I mentioned this interesting technical challenge where every day we have massive spike in requests per minute to our backend services. And this challenge forced the adoption of microservices architecture at Guild. At the moment, there is about 300 services, microservices, supporting our backend. And as this number grew, we decided that we need to figure out how to standardize our way of working with backend services. And this inspired the development of Apidoc project. Apidoc is an open source project that provides documentation, and it generates native client libraries for your backend services. So it basically lets you describe your backend services in an intuitive JSON format. So here is an example of API.json descriptor. So you start with defining models, then you map those models into resources, and those resources expose specific operations. So once you define this API.json descriptor, you upload this to Apidoc, and in return, you will get very nice documentation for your service with all the endpoints and resources that are available. And also, you will get client libraries. So it's generated code that is ready to use, and it's actually very useful for both front-enders and back-enders. And as you look at this set of features, so you can create some descriptor for your service, and then you will get in return the documentation and generated libraries. Does this set of features ring any bell in your head? Like, have you seen something similar anywhere? Okay. Exactly. I just wanted to ask who has started thinking about Swagger right now. So at least 1, 2, 3 people. Okay, yeah, so the question is obvious. Why have we decided to implement something so similar to Swagger? It's basically an alternative solution. And here is the answer. So this is Michael Bryzek, co-founder and ex-CTO of Guild, and he was the main guy who developed Apidoc. And he was asked, have you found Apidoc better than RAM, Swagger, etc.? And he answered, I wrote Apidoc after evaluating everything on the market. The client libraries are awesome and other nice features. So basically, when we started thinking about Apidoc, Swagger was in his previous version. And there were features missing, and we were basically not satisfied with the solution. So we just decided that we want to implement something that is better. So we did it, and it has been serving us really, really well. Okay, I'll go back one slide to the client libraries. So if you go to Apidoc website and look at the list of client libraries, you can be disappointed because you will not find Swift there. So you'll think, okay, this is kind of useless. However, it's actually possible to generate Apidoc client. There is another open source project developed at Guild. It's called Apidoc Swift Generator. and it does exactly what the name suggests. So based on the service descriptor and API doc, it will generate the client for you. And to show you how this works, I developed an example, simple application that is communicating with Foursquare API. Are you familiar with what Foursquare is? I assume people know. It's just this service for exploring and discovering places given the location and the query. So for example, you can ask, find me places with beer near Dublin, and that's the list that the API will return. So let's assume that this is the user interface that we want to create. And to implement this application, I also created a description of Foursquare API and API JSON. So I will go a few slides back. So I actually created this Foursquare service in API doc, and it's publicly available. So if you go to API doc and click on Natalia organization, you will see this API. And I just decided to expose one resource for the venues and two endpoints, one for exploring the venues nearby location, and the other one for getting the details of our venue. I needed two because the first request only returns the name of the venue and the ID. However, for my user interface, I also wanted to display the photo of the venue, so I needed to make another request to get the details of the venue, and that would include URL of the photo. Okay, so the work, actually every initiative at Guild starts with those two things. First of all, we create user interface. So we work with designers to figure out what will be the experience for our customers. And then front-enders and back-enders sit together, and they work on defining this API doc description of the service, because this will serve as a contract between front-end and back-end. And front-end services will be front-end applications will be relying on these back-end services and on those endpoints. Okay, so back to our application that we want to implement. If you want to follow the steps that I will be following, I created skeleton application. You can visit my GitHub page and just check out the skeleton application branch. So we start with just the user interface implemented and showing some mock-up data, venue 1 and venue 2. And I wanted you to pay attention to dependencies of this project. We use Carthage as dependency manager. And we have 4 dependencies. 3 of them are actually from Cleanroom. So those are the open source modules that I mentioned that we created in Swift. And the last one is PromiseKit. It's another very good framework for working with backend services. And I'm going to talk more about this at the end of my presentation. Okay, so we have our skeleton application. Now, how do we generate our Swift client? First, you need to get this API doc Swift generator project. So you just use git clone. Then you open it in Xcode. And you just need to build this project to enable running tests. And this project, API doc Swift generator, is a very young project. So you will notice there are still some rough edges here and there, and the whole workflow is not entirely smooth, but just consider it as work in progress. We are still working on that. So you need to go to, so actually generating clients happens through running tests. So you need to go to API endpoint tests and update few keys. So you need to update the organization key, application key, the path and folder name where you want your resources to be generated. And then you just hit run test integration. And if this succeeds, this will be the result. So in the location, you will see the generated Swift file for our Foursquare API. So we have those 2 resources that you should remember from our API doc descriptor, one for exploring venues and the other one for getting the details of the venue. And under the model directory, there is our data model to work with this service. And this is example data model file describing the photo of the venue. So you can see it was generated as a structure, and it can be initialized with the JSON payload, and there is also 2JSON method for serializing back to JSON. So the great thing about code generation is that this repetitive task of parsing JSON into data model and back is just done for you. You just click one button and this code is generated for you, and you can use it straight away. And here's an example how you can use the generated data transaction. So what you need to do, you need to initialize this venue get venues explore data transaction. And this name may be a bit too long for you. You may think it's like not the best name, but to justify it, it's actually using the name of the resource, the operation, and the parameters that you defined in Apidoc. This is what constructs this name. So we are creating new data transaction for exploring the venues. And then if you want to execute this transaction, you just call execute transaction, and this will be an asynchronous call. And then when you get the result back, we do pattern matching on the result. And in case of successful result, we can process the response. And if something failed, you can proceed with displaying error or logging the error. It's up to you. So this is the basic usage of transactions. Now, quite often, you will need something more than just executing one asynchronous request to actually build feature-rich user experience. Most probably, you will have to call many different services. Maybe you will have to do some parallel HTTP calls, HTTP requests. Maybe you will have to wait for one request before doing the another. Maybe you will have to merge the results. So there's many interesting scenarios that you may have to implement in your client application. So here is another open source framework that I wanted to share with you. It's called PromiseKit. And it provides implementation of promises, asynchronous patterns, chaining, and parallel calls. The concept of promises probably is familiar to most of you. It's been around for a few good years now, especially in the JavaScript world. And a promise is a concept of the result of asynchronous call. And it is a nice alternative to callbacks. And together with those asynchronous patterns, PromiseKit can really detangle your code and help you to write beautiful code for interaction with backend services. And here you can see instance methods and class methods for promise in PromiseKit. So basically, this is the toolbox that you can start using once you import PromiseKit into your project. So this is how some consecutive API calls could look like in Swift. So you can use firstly, then do first API call, then do another one, then do another one, and so on and so on. So that's the way of chaining them. So how can we use PromiseKit with the client that we generated using Apidoc Swift generator? You do need to add a little bit of code. So first of all, you need to wrap this execute transaction into a promise. And for this, we created an extension to data transaction. And you can also wrap the creation of the data transaction and the call to the promise, the execution of the promise, into a nice function that will just take the input parameters and return a promise. So for the function search for venues, we take the query parameter, and it will return a promise of an array of venue. And for getting venue details, we take venue ID, and we return a promise of a venue. And now, that's the grand finale of the whole service integration. So that's the code that can actually do something really interesting. So first of all, we want to search for venues, and then we will be able to work with the collection of venues, which will be the result of this call. If something goes wrong with this API call, we will end up in this error handling code block. But let's assume it's the happy path. So we got the venues. Now, for every venue, we want to be able to obtain the photo of this venue. So for every venue, we want to call get venue details. So maybe one step back. So now the venue details promises, the type of this is actually an array of promises, because it's a bunch of API calls that are waiting to be executed. So it's an array of promises. And because they are all independent, it would be cool if we could just execute them in parallel, just to speed things up. And this is exactly what when can be used for. So when takes as a parameter a collection of promises, executes them in parallel, and then collects back the results. So as a result of this call, you will get a collection of venues with details, and then you can just proceed with reloading the table view in your user interface in your view controller and displaying the data. Also, there is always that you can use, and it's like finally. So when you need to clean up something, for example, here I am just hiding progress indicator. No matter if that was successful call or if that call failed, we'll always hide progress indicator in the user interface. So if you want to see how this application actually works, okay, I'll try to make it bigger. Okay, I think this will do. Okay, so what would you like to search for? Any suggestion? Except for beer. We already searched for beer. We need something else. Coffee, okay. Okay, sorry, that was just some breakpoint in the code. Okay, anyway, we got the list of coffee places, so Brother Hubbard, the family, and so on. Not sure if those are the best coffee places, but this is what Foursquare API returns. And you can actually click on the list item and see the picture. Okay, so this is very simple application, but I hope it was good for showing how you can combine working with different service calls and building more complicated view models based on different data. And I have one last slide to finish up, and this is actually a riddle for you guys. On the left side, you can see an ancient mosaic from Pompeii in Italy, presenting a dog, and what says at the bottom is Cave Canem. And on the right side is our guild tag logo, featuring a cat. I think it's a cat. I'm not really sure, but I think it's a cat, like a big cat, probably a panther. And it says Cave Laborem. Has anyone any clue what is the story behind those two images, and actually what does our logo mean? Anyone? Any ideas? Anyone familiar with Latin? What can be this Cave Canem? What can this mean? Mind the dog. Yes, fantastic. Exactly, it can be translated as beware of the dog. It's like there is a dangerous dog in this household. Beware of it. So now, what do you think? What can be cave laborem? What can be the meaning of cave laborem? Mind the work. Yes, be aware of work. And what does it actually mean? So at Guild, we believe that work should not really feel like work. If you think of work as something negative, as something that is boring, maybe repetitive, that you don't really enjoy, then you must be doing something wrong. We believe that engineering should be really fun and enjoyable all the times. So this is why we created this logo to remind us, be aware of work. If it feels like work, then maybe try to optimize something, maybe try to use different technology, different tools, maybe automate the tasks that you have to do every day. This is why we implemented API docs with the generator to have something automated. And then maybe you will be able to enjoy your daily routines again. So if you feel that your work feels like work, we're hiring. So feel free to ping me if you'd like to know more details. Also, if you have any questions in regards to those frameworks that I presented, feel free to reach out. Thank you. Yes, we use the latest version, yeah.
The second question is about promise kit, but how with the array of promises? Yes, with the array of promises. If at least one promise.
If it fails. Mm-hmm.
Yes, you will automatically go to error.
Yes, that's correct.
That means that you will not see.
Yes, that's correct. There is no workaround at the moment. There is when, there is also join, and the difference between them is that when will automatically proceed to the error block on the first promise that is rejected, whereas join will wait for all promises to return, and then will go to the error. That is the only difference. But there is no way of figuring out which promise actually failed. You just know that one of them failed, and that's it. That's the limitation of the API. Yes? Which one?
The list of instance of class methods. It's algo one. Yeah, there.
Second from the bottom. I have no idea. But feel free to check it. I just copied those instances today. Yes? We really liked the concept of promises and those asynchronous patterns. So when, then, always. We played with that, and the code that we produced was really nice and concise. And we decided, yeah, let's go with it. It's just nice. It looks nice. Yeah. From JSON. So you create API JSON. There is a way to generate this JSON. Well, API doc is compatible with Swagger service description. So if you go to Apidoc, you can submit the Swagger. I don't know if that's the Swagger JSON format, but you can submit this, and Apidoc will know how to create your service out of this. And Apidoc will turn this into API JSON format.
Why did you choose to be test instead of special target things?
It's a good question. I haven't developed this project. It was another developer. I assume it was just pure convenience. He was writing tests anyway, and he decided that the easiest way to run something is just click the run the test button. But definitely this can be improved. I agree it's not the best workflow, and it can be much better. Ideally, you would create some CLI tool where you just type the command in your shell, and it will generate the client for you. How would you know what is live on the backend at the moment? Like, how would you do the service discovery part?
Square are pretty good about doing the state versions of their APIs. APIs like Jar. My only thing, or my observation about like
No, we're not. So for now, this is the solution that we figure out. Of course, there is many ways, as in any development challenge, that you can solve the problem. So.
yeah, GraphQL. One company. If you use Rails, you can extend it. If you extend your that's what we are like.
Yeah. Yes, I will share the slides, and like the code of my application is on GitHub. It's public repository, so you can either download the final version of the application and see how it works, or you can download the skeleton version and then try to work through this and generate the client based on Apidoc. This should also work for you. If you hit any troubles, let me know. I'll be there to help you. Thank you.